Hello, it's Dr. Mike here, and welcome to my review of the Ultimaker 3 Extended 3D printer. We will be looking at the Ultimaker 3 Extended specifically from the perspective of medical and medically related 3D printing, which is my area of special interest. Medical models are much more challenging to 3D print compared to engineering models because of their complex geometries and relatively large size. We'll see today if the Ultimaker 3 Extended is up to the challenge. The Ultimaker 3 Extended is the big brother of the regular Ultimaker 3. Both printers are FDM or fused deposition modeling printers with dual extrusion nozzles, which is an improvement over the previous generation of single nozzle FDM Ultimaker 2 printers. Dual extrusion makes it possible to use two different materials when 3D printing. This means one of the extruders can use a build material and the second extruder can use a support material such as water-soluble PVA. This is particularly interesting if you're doing medical 3D printing because the complex geometries of anatomic parts often require use of support material that can be difficult to remove. Water-soluble PVA can easily be washed away with tap water after the print is completed. The Ultimaker 3 Extended retails for $4,300 US. It has a build volume of 8.5 by 8.5 by 11.8 inches or 21.5 by 21.5 by 30 centimeters. This is the same platform size as the regular Ultimaker 3, however there is an additional 3.9 inches in vertical build height, which is handy when printing larger anatomic parts. The printer requires minor assembly before using, has a heated glass build plate, and prints in layers as thin as 20 microns. It supports filaments made out of nylon, PLA, ABS, CPE, and PVA. Material cost is variable depending on the type and brand of the material, but as a baseline, PLA material from Ultimaker costs about $50 for a 0.75 kilogram spool. The printer is run using the Cura software, which is free for download and available on Macintosh, Windows, and Linux computers. The Ultimaker 3 Extended comes in a large box that contains 2 rolls of filament, a power cable, a quick start guide, XY calibration guide, glass build plate, a few tools, an Uhu glue stick, bicycle chain lubricant, Ethernet cable, USB thumb drive, and filament holder. It comes with 2 extrusion cores. There's a small calibration card, which you should keep. Make sure you don't lose it as you'll need it. You'll need to take the filament holder and attach it to the back of the printer. A cable connecting an embedded filament detector needs to be plugged into the port on the bottom of the printer. A cable guide cover also needs to be attached. The glass build plate easily slides onto the build platform. Once everything is assembled, you can plug in your printer using the relatively large AC adapter. At this point, instructions will be shown on the small display on the front of the printer that will help you to install your 2 print cores. Slide the print cores into position in the print head. Make sure to adjust the locking lever to lock them in place. The print cores should be automatically detected. Next, you will load the filament into the filament holder and feed it into the extrusion system. Manually feed the filament into the motor. You will notice that the filament begins to slowly advance. Eventually, molten filament will begin coming out of the nozzle. The filament is now loaded. You will repeat the same process for the second extruder. Finally, follow the instructions to connect to your Wi-Fi network or plug the printer in using an Ethernet cable, and you should be ready to go. For my first print, I made a lumbar vertebra using the silver PLA with PVA support. This model is relatively small, but I wanted to see how the printer did with a small model to start, and it performed without a hitch. After it was completed, I dunked the model in water and the PVA support dissolved in a few hours. The final part looks terrific. For my second print, I made a celiac artery model that is slightly larger but still no more than about 3 inches high. Again, this printed without a hitch using silver PLA with water-soluble PVA support. The final part looked great. I did run into some trouble when I removed the BB print core. Somehow I got into a situation where the printer was asking me to insert the print core, but I was unable to do so because a piece of filament was blocking the way. The printer insisted that I insert the print core, and there was no way for me to exit out of the menu or tell it that I was unable to install the core. On multiple occasions, I ran into trouble with the simplistic menu instructions that do not account for the possibility that something could go wrong, and the printer is instructing me to do something that cannot be done. There's no way to exit out of the menu other than to shut down the printer. In this instance, I was able to disassemble the feeding tube, called a Bowden tube, and remove the obstructing piece of filament. After this was done, I was able to insert the print core. For my third print, I decided to make something more ambitious. I chose to print a full-sized brain. The brain is a difficult print both because it is large in the X, Y, and Z dimensions, and also it is geometrically complex with a lot of cavities and contours. 3D printing of large and complex models is where I hoped the Ultimaker 3 Extended could really perform. However, this is where I started to run into more problems. My first 3 attempts didn't succeed for a variety of reasons, and I don't have good video of them. Attempt number 4 failed because the first few layers would not stick to the build plate. I fixed this by applying glue to the build plate, which is a recommended solution from Ultimaker. Attempt number 5 failed because the PVA support material ran out in the middle of the print. The Ultimaker 3 does not have a way to detect when material runs out, so the printer just happily keeps on printing, oblivious to the fact that it has run out of material and nothing is being extruded. You can see that the white material continues to print, but the transparent PVA support has run out. During my 6th attempt, the printer stopped for no apparent reason. This might have been due to a software crash. In any event, it was printing normally, and all of a sudden the print head stopped. I was unfortunately away when this happened, and the print cores remained hot after the printer stopped. The PVA support material decomposed inside the second print core and turned into a carbonized mass, which then clogged the core. I ran into a lot of trouble while trying to fix this problem. First, I somehow got into an infinite loop with the printer repeatedly giving me the same warning. No matter what I did, I could not exit out of the recurring warning message, and the printer kept showing me the same warning message again and again. When I finally got this problem resolved, I performed a hot pull several times. This is when a spare piece of filament is pushed through the obstructed hot print core and then rapidly yanked out. The idea is that the obstructing material will get pulled out too. Unfortunately, this didn't solve the problem. Next, I transitioned to cold pulls. With this technique, filament is pushed manually into the hot core, and then the core is allowed to cool. The filament solidifies, presumably sticking to the obstructed material, and then the filament is then violently yanked out in an attempt to dislodge the material plugging the core.
And you get jerk.
I tried this several times without success. I became somewhat concerned with this technique because I thought it could break the printer. But the Ultimaker website says this is an established means of clearing a clogged print core. Next, the Ultimaker website recommended that I try unclogging the nozzle using an acupuncture needle. The problem is that acupuncture needles are restricted medical devices and are only sold to people who have a state acupuncture license. Obviously, this wasn't helpful to me. Now, I'm a medical doctor and I tried to purchase acupuncture needles, but because I don't have an acupuncture license, but rather a medical license, I was not able to get them. I tried to unclog the nozzle using the finest clothing needles I could find at the local megastore, but even these small needles were far too thick to be used. I finally broke down and purchased a brand new print core from the Matter Hackers website at a cost of $125 US. This turned out to be a very expensive and time-consuming printer crash. With the printer working again, I attempted brain print number 7. I switched the printer from normal to draft mode, which prints thicker layers at a faster speed. The estimated time of the brain print went from 7 days to 3.5 days. With my 6 prior failed attempts and an estimated print to completion time of 7 days each, I'd spent almost a month trying to print this brain by this point. I made sure that I had full spools of both PLA build material and PVA support material. Much to my delight, the print was a success. There was a bunch of loose filament stuck to the model at the end of the print, which I was able to remove easily and didn't seem to impact the overall quality of the print. I put the completed print in a glass vase to dissolve the PVA support material, and it worked like a charm. It was actually pretty cool watching the PVA slowly dissolve over the course of several hours. I removed the model, washed it thoroughly to get rid of any residual PVA, and allowed it to dry. As you can see, the quality of the print was terrific. At this point, I decided to take things a step further and print a complex 2-part lumbar spine model that was pretty tall. My first attempt failed after 2 days when again I ran out of filament. I actually knew I was running low and had intended to check on the print in about an hour, but became distracted, and by the time I got to it, the filament had run out and the print was ruined. This seems to be a problem with the Ultimaker 3 in that if you're not 100% on top of your prints at all times, a multi-day print can easily become ruined. The Cura software has a feature where you can watch your print progress through a camera on the printer over your network. In theory, this would allow you to monitor the status of your print while you continue to do work on your desktop computer or laptop. However, I found that after about an hour or two, the printer camera disconnected from my desktop computer and would not let me monitor the print. This occurred when the printer was both on Wi-Fi as well as hardwired using the Ethernet cable. I'm not sure if this is a problem with my network or the printer or the Cura software, but the net result was that I was not able to monitor my prints in real time. My second attempt at printing the lumbar spine appeared to be successful. I did have to change filaments mid-print, but was able to catch the low filament level before it was too late and replace it with a new spool in the middle of the print. When completed, I put the model in water to dissolve the PVA support material, which looked very cool. However, when the PVA material was removed, the model broke apart. I think there was a weak layer at the level I replaced the filament at. The model came apart at that layer and was ruined. My third attempt to print the lumbar spine was really frightening. I've had lots of problems with build plate adhesion by this point. This means that the initial layers of the print do not stick to the glass plate. I tried to correct this by applying glue to the plate, a recommended solution by Ultimaker. But if too much glue is applied, it can cause problems with the printer improperly leveling the build plate due to the irregular surface. During this third print, the initial layers came off of the glass plate and became entangled in the printer head. They then snagged part of the model that was already adhered to the plate and ripped the glass plate off of its supporting base, almost knocking the glass plate out of the printer where it could shatter on the floor. As you can see from this footage, this was pretty scary, and I would not want this to happen at night or during a weekend print when nobody was around. My fourth attempt to print the lumbar spine also had problems with build plate adhesion. It seemed that the PVA material did not want to stick to the plate. Fortunately, I caught this early and aborted the print. My fifth attempt to print the lumbar spine similarly had the same problem where the glass plate almost got pushed out of the printer and broke on the floor. The cause was the same, the poor adhesion to the first layers of the build plate, which caused them to become entangled in the printhead and eventually ripped the plate from its base and nearly pushed it out of the printer. This is not a good situation. After this second experience with nearly breaking the build plate, I decided it was not safe to continue to try and print this lumbar spine model. I've had the Ultimaker 3 extended for about 4 months now and have had very mixed results. On short models, the printer seems to perform quite well, printing both the lumbar vertebrae and celiac artery models on the first try, although I did run into some trouble with the glitchy firmware instructions on the celiac artery model. For larger and taller models, performance was much less impressive. I successfully printed a full-size brain after 7 tries and was not able to print a tall lumbar spine model after 5 tries, almost breaking the glass build platform twice. In total, I had 3 successful prints in a total of 11 attempts, a 21.4% success rate. The pros of the Ultimaker 3 Extended are its large build volume, inexpensive material, availability of water-soluble support material, and good performance on short prints. Cons are unreliability on tall prints. It is very slow, with full build volume prints taking up to a week. It requires a lot of maintenance and supervision, and has glitchy and occasionally nonsensical firmware. For a garage hobbyist with lots of free time, these shortcomings may not be much of a problem, although the $4,300 price tag may be prohibitive for most hobbyists. For medically related applications, such as printing models for patient education, surgical planning, device testing, or medical education, the Ultimaker 3 Extended has significant shortcomings. The combination of slow print speed and high print failure rate for anatomic parts is a problem when a surgery or patient visit is scheduled on a fixed date. Furthermore, the need for constant supervision is an issue in a busy office or clinical environment where staff have other things to do and may not be available to supervise the printer at night or on weekends. The main drawback from a medical 3D printing perspective is the lack of reliability on large prints. Build plate adhesion is a major problem, which can be addressed with application of glue to the build plate. This is a delicate balance, however. Too little glue and the first layer will not adhere to the plate, but too much glue and the print surface will become irregular and the printer will have a hard time with build plate leveling. The best way to be sure that the print is properly adhering to the build plate is to monitor the first layer or two. This can take up to an hour though, and in a busy clinical environment where everybody is pressed for time, this may not be practical. Another major issue that affects reliability is the lack of filament monitoring. Large prints can take a week or longer and can consume a whole spool of filament or more. With 2 extruders, the printer has twice the likelihood of running out of filament in the middle of a print. Because the printer doesn't know how much filament is left, it is up to the user to constantly monitor the filament levels and pause the printer and replace the filament when needed. With large prints taking up to a week, this means checking on the printer daily and trying to guesstimate when the printer will be low on filament to schedule a reload. If you are late by as little as 10 or 15 minutes, your entire print can be ruined, as happened to me multiple times. The Ultimaker 3 Extended and its little brother, the Ultimaker 3, are definitely a step up from the prior generation of Ultimaker 2 FDM printers. However, they are not quite ready for prime time for medically related applications. Other printers in this space, most notably the Form 2 printer from Formlabs, are much more reliable. The Form 2 does have a smaller build volume and does not have water-soluble support, but at $3,500 US, it is $800 less expensive than the Ultimaker 3 Extended. If you decide to purchase an Ultimaker 3 Extended, make sure you also have a good set of pliers.
And you
I hope you have enjoyed this review of the Ultimaker 3 Extended 3D printer. I tried to be as thorough and objective as possible. If you want to know more about medical 3D printing, please visit embody.com, where you can view dozens of free tutorials and download hundreds of medical 3D printable files, all for free. If you like the review, please give it a thumbs up. If you are interested in other reviews and medical 3D printing related content, please hit the subscribe button. If you are interested in watching my review of the Formlabs Form 2 printer for medical 3D printing, there is a link in the description below. Thank you and happy 3D printing.